Problem 1. Generate the Hamming code for the data 0110101. Assume the parity code is even. So for this data, the data is of length 7. So the data length is 7, and so for this data, the number of parities used is 4. So 4-bit parity we will use here. So 7 plus 4 is equal to 11. So we have, so the Hamming code will be of length 11. So here we know the positions allotted for the parity, that is I already explained in my previous video. The position allotted for the parity is first position P1, then second bit position, then fourth, then 8. The rest of the position is for data. So here data bit will come, data D6, D7, D9, D10, D11. So here, so for the data from here you can take, so the first bit will be for D3, next one is for D5, the next one is for D6, then the 0 for D7, then 1 for D9, 0 for D10, again 1 for D11. So you have to take this data and put it in the corresponding position. Now we need to find the 4 parities P1, P2, P4 and P8. So to find this, so first let us find the first parity, that is P1. P1 is found by using XOR of some data bits. So you have to do XOR of some data bits to find P1. So we should know which data bits we should take to find P1. So for that, let's refer this table. So here this gives the bit position. The first column refer to the bit position 1 to 11, and the next column is the equivalent binary number for the corresponding digital decimal number. So this, the first bit position, the first bit position, that is 1, it is for parity P1, this is for parity P2, this is D3, P4, D5, D6, D7, this is P8, D9, D10 and D11. Okay, now so to choose the data bits to find the parity P1, we have to see among the data bits, we have to see which of that in the first has 1 in the first position, that is here in binary this is position 1, this is 2, this is 4 and this is 8. So in the first position where 1 is present among the data bits, so here among the data bits D3, here 1 is present, then in D5 yes 1 is present, D6 no 1 is not present in the first position, D7 1 is present in the first position, D9 also 1 is present in the first position, D11 also 1 is present in the first position. So we should choose these data bits and do XOR here. So it is D3 comma D5, D7, D9, D11. So that is equal to XOR of D3 is, the value of D3 is from the data from here you can see it's 0. So here the value of D3 is 0, D5 is 1, D7 is 0, then D9 is 1 and D11 is 1. So 0, 1, 0, 1, 1. So here in XOR, odd number of ones means we will get the output 1. So the answer is 1. So now P1 is 1. So that you can write here in the P1 position. So the P1 is 1. Next, let's find P2. XOR of. So let's find the data bits. So here we have to see the second position, that is this one we have to see second position. So among the data bits, in the second position wherever 1 is present, we are going to now check. So here, so in the data bit second position is okay. So here it is in D3, then in D6, D7, then D10, then D11. So let's write. So it's D3, D6, D7, D10 and D11. So that is equal to XOR of. So D3 is 0, D6 is 1, D7 is 0, D10 is 0, D11 is 1. So even number of 1, so the output will be 0. So right here P2 is 0. Next, P3 is equal to XOR of. So we have to now choose the third position, this one, and check among the data bits where in third position 1 is present. So here 1, 1, 1 in D7, then yeah, only in 3 positions. So it's in D5, D6 and D7. So D5, D6 and D7. So that is equal to XOR of. So D5 is 1, D6 is 1 and D7 is 0. So that is equal to 0. So even number of 1, so the output is 0. So P3 is 0 now. Sorry, it is P4. This is P4. So P4 is 0. Okay, next we are going to do P8. So P8 is equal to XOR of. So let's choose among the data bits the fourth position. In the fourth position 1 should be there as a fourth bit. So 1 is present here in D9, D10 and D11. So it's in D9, D10 and D11. So that is equal to XOR of 1, D9 is 1, D10 is 0, D11 is 1. So even number of 1, so output is 0. So P8 is 0. So this is the Hamming code. So the Hamming code is 1 0 0 0 1 1 0 0 1 0 1. Problem 2. Detect the error in the Hamming code. So the Hamming code is given. Now we have to find whether there is any error and detect in which position the error is present. So first let us assign the positions of these parity and the data bits in this Hamming code. So here this bit is for parity P1, P2, D3, P4, D5, D6, D7, P8, D9, D10, D11. So here there are 4 parities present. So we have to now find 4 check bits. So from the check bits we can detect the error in the Hamming code. So since there are 4 parity bits, we will now create 4 check bits. So here, so now we are going to find check bits. So first check bit C1 is equal to XOR of P1 comma. So for the first check bit we are using the first parity bit P1. Then we have to choose the data bits. So data bits, as I said in the previous problem, we can use this table and find the data bits. So the data bits, that is in the position, in the first position, in among the data bits, in the first position, wherever 0 is present, wherever 1 is present, we have to choose. This is similar to the previous problem. So you can choose the data bits in that way. So here, as I said in the previous problem, here the data bits, the having 1 in the first position is D3, D5, D7, D9, D11. So this is equal to XOR of P1 is 1 and D3 is 0 and D5 is 1, D7 is 0, then D9 is 1, D11 is 1. So that is equal to, so here even number of 1s, so the output is 0. So C1 is 0. Next is C2. So same XOR of P2 here we'll take. Then the data bits that contains in the table that contains 1 in the second position we are choosing. So that is D3, D6, D7, D10, then D11. So that is equal to XOR of P2 is 0, then 0, 1, 0, 0, 1. So it is a even number of 1, so output is 0. Next C3 XOR of C4 XOR of P4 comma, then in the table the data bits having 1 in the third position. So here it is, so it is D5, D6 and D7. So that is equal to XOR of 0, 1, 1, 0. So that is equal to even number of 1, so output is 0. Next is C8 XOR of P8 comma. So in the table the data bits having 1 in the fourth position. So that is D9, D10 and D11. That is equal to XOR of 0. So P8 is 0, then 1, 0, 1, which is equal to, so even number of 1s, output is 0. So all C1, C2, C4, C8 all are 0. So now the check bit C is equal to C8, C4, C2 and C1. So C is equal to, so C8 is 0, C4 is 0, C2 is 0, C1 is 0. So when C is equal to 0, 0, 0, 0 means the meaning is there is no error. There is no error. The Hamming code is correct. So there is no error in the Hamming code. Problem 3. Detect the error in the Hamming code. The parity code is even. So this is the given Hamming code. So first let us assign the position of the parity and the data bit. So this is P1, P2, D3, P4, D5, D6, D7, P8, D9, D10 and D11. So here, since here we are using 4 parities are used in the Hamming code, so we have to find 4 check bits. So to find the check bit, I have already discussed in the previous example, in the previous problem, how to find the data bits for the C1, how to find these data bits. I already explained in the previous problem, so you can use that method. So C1 is equal to XOR of, so P1 is 1, so 1 here, then D3 is 0, D5 is 0, then D7 is 0, D9 is 1, D11 is 1. So here odd number of ones, since we are using even parity, since it's an odd number of 1, so the output will be 1. Next is C2. So let's find C2. So that is equal to XOR of P2 is 0, D3 is 0, D6 is 1, D7 is 0, D10 is 0, then D11 is 1. Even number of 1, so the output is 0. Next is C3. So C3 is equal to XOR of, so P4 is 0, D5 is 0, D6 is 1, D7 is 0, so odd number of 1, so the output is 1. Next is C8. So that is equal to XOR of P8 is 0, D9 is 1, D10 is 0, D11 is 1. So even number of zeros, so the output is 0. So here now C is equal to, the check bit C is equal to C8, C4, C2 and C1. So C is equal to C8 is 0, C4 is 1, then C2 is 0, C1 is 1. So it is C is equal to 0, 1, 0, 1. The decimal equivalent of this is 4, 5, 5. The decimal equivalent of this is 5. So that means the fifth, there is a error in the fifth bit. So this is the fifth bit. So this is the fifth bit. So there is the error in this bit. So the correct Hamming code is 1 0 0 0 1. Since there's an error in this, I'm correcting it. 1, then 1, 0, 0, 1, 0, 1. So this is the correct Hamming code, and the error was found detected in the 5th bit.